I'm so tired. How are you guys doing today? Oh, he has got to go.
Where is it going to go?
Oh, do you know how much dinosaurs go to the bathroom?
What
Oh,
does
gosh.
And they try to eat everything!
Oh,
What did they eat?
oh,
Is this a
yeah.
meat eater yet?
That chili was a bad idea.
Yes! Try fixing the time
Is there any dorks around?
Oh,
No.
no, you're good. Come on in. Did you finally get to go to sleep?
Yes, I finally got into sleep.
Oh,
We can't keep doing this. I have got to get that time machine fixed.
Yes, we got to take it back!
his cute is wearing out, I tell you.
Oh yeah, his cute wore out about 2 weeks ago. Oh, you know, I am so pooped, I'm not even thinking straight. I put my water in the freezer and now look, it's solid as a rock. And I'm dying of thirst.
Why'd you do that?
I don't know, I guess I'm just not quite thinking straight right now, you know, with all the baby chasing and stuff. I don't know, it's like,
Well, it's like a rock.
it is, it's like a rock. Look at that. Isn't it neat how water expands when it's frozen?
Well, yeah.
Why is it heavier?
Well, you know, that's a good question. You see, water actually has, I'm gonna finish. I'm not talking with my mouth full of ice. Hear it hissing?
Yeah.
Water actually has 3 stages that it's in. It actually is also not only a liquid, but it's also a couple of other things. Does anybody else know what it is? It's a solid, that's right, and there's also something else.
A gas.
A gas, you're correct. Water is not only, the kids are very smart, by the way. The water actually comes in 3 stages. It's a water, it's a gas, and it's a liquid, a gas, and a solid. And so it gets heavier when it gets frozen because all of the molecules combine to make it hard as a rock. Feel how hard that is.
Oh, right. It is so cold.
Yep, when it gets cold like that, that's when it begins to freeze. Do you know what temperature it has to be for water to freeze?
About 37. 38.
Close. Anybody else know it?
42. 42.
No, it's a little colder than that. What?
38.
Huh?
109.
What? No, lower than 36. 32 is correct. Who said 32? 32 is correct. When it gets to 32 degrees Fahrenheit, the water becomes a solid. It gets so cold that the liquid actually will begin to freeze and will stay this way. Now, this has been out of the freezer for just a few minutes and my hands, which were once warm, are not no longer. Now it's starting to melt a little bit because my hands are a lot warmer than 32 degrees. The hotter that this gets, the quicker that this will begin to move. So if I was to put it, say, under hot water and put it in a sink and turn the hot water on, it would melt it a little faster because of the heat coming into it. The heat will do it. So the hotter that it gets, the faster that it will melt. And see how it expands when it's frozen? So a while ago when it was sticking up over the top here, it expanded. In fact, have you ever put a soda can in a freezer? Anybody ever done that? It explodes, that's right, because when liquid is in a solid state, it actually expands. But what would happen if I was to leave the lid on this airtight and sit this down and not use it? Do you know what would happen to that plastic bottle? No, it wouldn't do that. It'd do something different. It collapses because of the gas inside of the bottle. The bottle would actually collapse the bottle and there would be wiggle room inside the plastic because of that. That's because water in its different states, it takes up less room as a gas, takes up more room as a solid than what it does as a liquid. That's why everything changes from time to time. And it's extremely cold. Yes, it's extremely cold. Yes.
So, if it freezes at 32, then at 33, then it's automatically unfrozen.
Not exactly. You see, at 33 degrees, it would begin to thaw, but if it was, say, 85 degrees, it would thaw much faster.
So it starts to thaw at 30 degrees.
Yes, yes.
And it gradually gets to where it's water.
Exactly. It will gradually turn back into water, but if it was to get hot, it would no longer cease to be water. It would go up as a gas. Have you ever poured water in a bird bath?
Yeah.
Have any of you ever seen water go in a bird bath and then the water just disappear? Has anybody ever seen water disappear out of a bird bath? Why does the water disappear?
Hot.
Does anybody know?
It's hot. Yes. Hot. Because it's clean.
Because it turns into a gas. That's correct. Through evaporation, the process of evaporation actually will cause the water to turn into a gas and then disappear. And that's because the water gets heated by the sun. If you have water and you put it in the bird bath at night, you should wake up in the morning and find still water in the bird bath. But if you was to put it out there in the middle of a hot summer day and set it in the bird bath, usually by the next morning that water could be completely gone because the water would leave and turn into a gas and go back up into the atmosphere. But the water is not really gone forever. The water will come back. Does anybody know how the water comes back after it disappears and goes up the atmosphere?
Rain.
It's right. It goes up, it forms clouds, and then comes back down as rain. And so when you're trying to make it rain on me, Gordon? Oh, I see. So when the water comes back down as rain, it actually comes back. Do you know that we have all of the same water on earth that we've always had ever since God created the world? All of the water is still here. Everything, even the stuff that we have drank, is still here, and it is cleaned and purified.
What about snow, Dr. Sparky?
Well, I wouldn't recommend eating yellow snow, but I will tell you about snow. Eventually, we will all eat yellow snow, whether you like it or not. Yes, this is a true story. You see, when we drink water and we release the water, I think is the best, nicest way to put it. You all know what I mean by that, right? When we release the water and it goes back, it actually gets purified a couple of different ways. Sometimes if you go directly onto the ground, it'll go through the rock and the dirt and it'll go back down and it will purify itself and come back out as pure, clean drinking water. Otherwise, parts of it will also be evaporated, will go back into the atmosphere, gets cleaned up in the atmosphere, comes back down as rain. So all of the water that we've always had has always been here. And so if you go home and tell your mom and dad that you drink pee, you are actually telling them the truth. It's just clean pee. Yeah, it's kind of disgusting. But you see, now we was talking about temperature a while ago. This is quite interesting. When the water in the atmosphere goes up into there and it turns into a gas and goes up into the atmosphere, if it is below 32 degrees, when it comes back down, it will come back down as snow. If it is, and it can still come down as a freezing rain or drizzle, even if it's around 32 degrees. Usually takes much colder air than 32 degrees sometimes for snow to form. But it has to be at least 32 in order to get a snow. Now we can get a snow that is a little bit above 32, but it'll be more of a wet slushy snow because it can snow and hit the ground, and if the ground is still warm, it will melt the snow and turn the snow back into water. So the ground has to have a temperature of 32 degrees in order for it to freeze.
Bridges.
Except for our bridges. And do you know why the bridges are colder? That's a very good statement, Electra.
Because the air underneath it.
That is true. There's no ground temperature underneath it, so the air is able to circulate, which would make the bridge much colder. That's why when you're driving, you have to be much more careful on a bridge because the bridges will freeze first. And if there is water underneath that bridge and the water is cold running underneath that bridge, then that is nothing there to warm the bridge, and that's why the bridge will be much colder and be much slicker in those temperatures.
So, is that why the North Pole is always having snow?
Well, that's a good question too, because you see the North Pole and the South Pole are the two coldest places on the planet. In fact, could I get one of you lovely ladies there in the back, could you grab me that globe and bring that up here? Oh, good. Very, very good. Yes. Tori, the birthday girl, you know, she just had a birthday yesterday. I believe she's 19 or 20. How old are you? 17. Oh, 17. She's 32. She looks much older than what she really is. That's not good later on in life, but right now when you're still young, it works. Yeah, this is a good example. Let me show you something here about this globe. You see, here at the top and the bottom of the globe, things are much colder here in these two spots. Way down here in Antarctica, this is considered the South Pole. Everybody say South Pole.
South Pole.
And way up here where you will find Alaska, Canada, Greenland, all of those up here, this is where the North Pole is. Yeah, where Santa Claus is at, right there, the North Pole, yes. Getting close to Christmas too, by the way. Anyway, up here, you will find the Arctic Ocean. A lot of glaciers and stuff up here in the Arctic Ocean because it is so cold. It never really gets below freezing. It never gets above freezing in both of these places. Now, the sun will come out, and the sun, because the sun's razor hot, it can melt some of the snow and the ice that is there. And even if it doesn't get a lot of precipitation, it doesn't leave because it is so cold. Again, if we were to take my water bottle, can I borrow that for a minute? Thank you, Gordon. If I was to take this and set it in the refrigerator, and then I got another one just like it and set it on the counter, which one would melt faster?
The one on the counter.
The one on the counter. Why?
Because the inside's hot.
That's right, because it's warmer on the counter than what it is in the refrigerator. Unless your power is out. And then it might be colder on the counter than in the refrigerator. That reminds me, do you know what they use refrigerators for? People who live in igloos? They actually use refrigerators to keep their food warm so that it doesn't freeze. That's just a tidbit of information. Yeah, because you'll have to keep it at a certain temperature so it doesn't get too cold. They don't need freezers, just refrigerators. The refrigerators will actually keep it warmer because it allows only a certain temperature inside the refrigerator. Interesting bit of news. Anyway, by setting this out here on the counter, this is going to thaw out a lot faster than if I was to take that out and put it in the refrigerator. It may take 2 to 3 days, depending on how cold the refrigerator is, for that to thaw, where I could sit this out and in about 4 to 5 hours, this would be completely melted out here on a counter at room temperature. So, same way it goes here on the planet. Right here, this is called the equator. You see that blue line right across there? Everybody ever heard of the equator? It's much warmer at the equator. In fact, that's the hottest place on the planet. So in the middle of winter, it'd be kind of nice to take a trip right here to South America and get into the equator where it's going to be much warmer. However, there was a time on the planet where things was not always the way it was. You see, up here in Greenland, they don't always have in fact, they never have a summer. It never gets hot and all the snow goes away completely. Never happens. Never, never, never. Down here, same way. It never gets hot, and then they'll have this really hot summer and all the snow is gone. Every time it snows, it just keeps getting bigger and bigger and bigger and bigger. Well, there was a time on this planet during the Ice Age where, do you know that it got just like that right here in Missouri?
All the time?
All the time. For about 700 years this Ice Age lasted. All snow, all the time for about 700 years.
Yeah.
We wouldn't have been able to make it then.
Well, you would have made a lot of snowmen and probably a lot of yellow snow, yes. So it actually reached all the way down here, which I'm sure we can talk about a little bit more about that later. But anyway, how did we get off on this while we were talking about that baby dinosaur?
Water.
Oh, my water. Huh. So tired and I still give a science lesson. Oh well. Anyway, maybe you understand a little bit more about ice and water, and that's actually quite interesting.
Door!
Oh, not the door again. We
Medicines, right? It's all Dr. Sparky's hot air.
It's your money!
So what's going on there, their bag of hot air? Ah! What are you doing? You poking at my face is fun?
What is coming this year?
I have a real problem. We've got to get out of here. If he's lurking around this close, the dinosaur is probably free. I tell you what, I'm going to put him in a position and stall him for a minute. Can you guys go take the baby dinosaur and put him in the secret spot? All
Bye,
right.
everybody.
Hi! Hi! I get headed back to the
Okay. Are you a little bitty baby?
No, I'm not a little bitty baby. So what is going on up here, Mr. Smarty Pants?
Just talking about frozen water and talking about the Ice Age to some of the kids out here. Actually, are pretty smart, know all about the Ice Age.
Oh yeah, Ice Age, yes, millions of years.
Millions of years ago, that's
Yes.
correct. Millions of years ago.
Yeah, so what's going on anyway? I thought I heard you talking in secret. Is there something going on I should know about?
Just working on another new project is all. Just got this new project
Is he hiding something?
in the works.
Are you sure?
Do you think they would tell you anyway?
I thought that they would, maybe, but oh well. Anyway, so well, you just enjoy your globe, mister, and your little gun, and I'm going to get back to Gerald, and we're going to be working on Jurassic Dark.
I think he means Jurassic Dork, don't you? I got an idea. You want to play along? He won't see me at all. Don't tell him I'm here.
And so then, where did Dr. Sparky go? He does not. People do not disappear. You're crazy. Fine, whatever. You guys just going to believe your fairy tales with your floating zoo and your stinking ice, whatever. Well, I'm out of here. Dr. Sparky, where did you go?
He's right there.
Where did you go? Ow! Ow! Tripped over the chair. Ow! You keep on laughing. I'll come out there. Wherever you went, Dr. Sparky. I'll get you one day. He's not right here. I don't see him back here. You got to let them jump back here, mister.
You almost knocked down the time machine.
I don't know how much longer I can take this.
Right there.
I know. I don't know how much longer I can take this. The baby dinosaur and the giant dork. Oh, it's gonna be crazy. I'll see you later, kids. I'm gonna go see if I can thaw out my water and get a drink. See ya.